You're not going to believe this. Two small spacecraft, built by us here on Earth, are now drifting alone through the endless dark, farther than anything humans have ever sent before. They carry a golden record, a message from our world to the cosmos, and they've redefined what it means to be explorers. This is the story of Voyager, humanity's greatest journey into the unknown, a mission that forever changed how we see our place in the universe. If you've ever wondered what it truly means to reach for the stars, you're about to find out. Space, the final frontier. Vast, dark, and breathtakingly beautiful, stretching farther than our minds can truly grasp. That's not just something from a TV show. It's a fact that's been true for as long as people have looked up at the night sky. Space is a vast, unexplored place beyond our little planet. It calls to us, asking us to find out what's out there. From the very beginning, humans have stared at the stars and wondered, what's out there? What secrets are hiding in the darkness between the stars? Are we alone? Is there life somewhere else, just waiting to be found? Now, picture yourself on a tiny spaceship, a small craft built by people, just a speck flying through space at tens of thousands of miles per hour, facing the cold and silence of the space between the stars. You're billions of miles from home, farther than anything humans have ever sent before, surrounded by the unknown. You're beyond the reach of sunlight, outside the familiar area of our solar system. And you're carrying a message, a golden record with music, languages, and the hopes of Earth. It's like a time capsule of what it means to be human. It's a greeting to anyone or anything that might find it someday. A simple hello from our world to the universe. This isn't science fiction. This is real. This is our story. It's the story of Voyager 1 and Voyager 2, two robotic explorers that have gone farther than anything else we've ever built. In this documentary, we'll look back at humanity's boldest journey into the unknown, a trip that changed how we see our place in the universe. We'll see how a rare alignment of the planets let these two spacecraft visit Jupiter, Saturn, Uranus, and Neptune in one trip. Something that could only happen once in many lifetimes. It was a grand tour of the outer solar system, giving us amazing pictures and data that changed what we know about these faraway worlds. We'll talk about the technology that made this possible. The smart engineering, creative problem solving, and determination that got the job done. And we'll meet the people behind it all, scientists, engineers, and dreamers who looked beyond what anyone thought was possible. But this isn't just a story about machines or about science and technology. It's about our need to know more, our curiosity that pushes us to ask questions and search for answers. It's about our drive to explore, to go further, and to step into the unknown, even when it's risky. To reach past what we know, to leave behind what's comfortable, and to take on the adventure ahead. To reach for the stars, to do what once seemed impossible, and to leave our mark on the universe. So buckle up and get ready for a journey like no other. As we travel together to the edge of our solar system and beyond, we'll see the victories and challenges of this amazing mission. Following Voyager 1 and Voyager 2, we'll discover not just the wonders of space, but also the lasting spirit of humanity. It was 1977. The world was buzzing with energy and change, a time of cultural shifts and scientific dreams. Disco was huge, lighting up nightclubs with flashing lights and catchy beats that defined the era. Platform shoes were everywhere, and bold fashion was the norm, showing a society ready to explore new ideas. In the middle of all this, two spacecraft, Voyager 1 and Voyager 2, were ready to launch. They were set for a mission like no other, a journey that would push the limits of technology and human curiosity. But it wasn't just about launching rockets. It was about taking advantage of a rare chance, a cosmic window that opens only once every 175 years, when the outer planets line up just right. The outer planets, Jupiter, Saturn, Uranus, and Neptune, were in a position that allowed a spacecraft to use their gravity to speed up and change direction, saving time and fuel. This gravitational dance, a cosmic game of billiards, offered a unique chance to visit all four giant planets in one grand tour. But the challenge was huge. Building a spacecraft that could survive such a long journey, lasting decades, meant overcoming many obstacles. It had to endure the cold of deep space, operate far from the sun, and send data back to Earth from billions of miles away. It required incredible ingenuity and innovation. NASA engineers and scientists rose to the challenge, dedicating their time and effort to create two amazing spacecraft. Each Voyager was packed with instruments to study the outer planets, capturing images, measuring magnetic fields, and analyzing the atmospheres and rings of these distant worlds. And so, Voyager 1 and Voyager 2 were born. They carried the hopes and dreams of our planet with messages and music from Earth, heading into the unknown. Their mission, to go where no one had gone before, to uncover the secrets of the outer planets, and to expand human knowledge further than ever. Little did we know that their journey would go beyond our wildest dreams. The Voyagers would travel to the edge of our sun's influence and beyond, into interstellar space, carrying the story of Earth and the spirit of exploration that defines us all. By 1979, after traveling more than 600 million kilometers, Voyager 1 and Voyager 2 finally reached their first big stop, Jupiter. Jupiter is the largest planet in our solar system, and it's been fascinating astronomers for a very long time. Jupiter is bigger than all the other planets put together. Its gravity is so strong that it acts like a protector, pulling on comets and asteroids, sometimes throwing them out of the solar system or pulling them in. It even has a small effect on Earth's path around the sun. As the Voyagers got closer, their cameras sent back amazing pictures of Jupiter's swirling clouds. For the first time, we could really see the details of its stormy atmosphere. We saw storms and jet streams moving in ways we'd never seen before, with colors and patterns that were even more beautiful than we expected. We also got our best look yet at the Great Red Spot, a giant storm bigger than Earth that's been going for hundreds of years. The Voyagers showed us its swirling layers and made us wonder how a storm like that could last so long. And the surprises kept coming. Every new picture and bit of data made the scientists and engineers back on Earth even more excited. One of the biggest discoveries was active volcanoes on Io, one of Jupiter's closest moons. We saw plumes of hot rock and sulfur shooting up from its surface, making Io the most volcanic place in the solar system. Imagine how the scientists felt. Before Voyager, we only knew about active volcanoes on Earth. Suddenly, we realized the universe was much more active and surprising than we thought. This changed what we knew about volcanoes. It showed us that volcanic activity isn't just something that happens on Earth. On Io, it's actually caused by Jupiter's strong gravity, which heats up the moon's insides and makes the volcanoes erupt. Io's volcanoes shoot out plumes of sulfur hundreds of kilometers high. Its surface is always changing, reminding us that the solar system is full of active, sometimes violent processes. The Voyagers also flew by Jupiter's other moons, Europa, Ganymede, and Callisto. These worlds looked strange and amazing, with icy surfaces covered in cracks. Some of these cracks might hide huge oceans under the ice, making us wonder if life could exist there. All these discoveries changed how we think about planets and moons. They made us ask new questions about life beyond Earth. Thanks to Voyager, Jupiter and its moons became real places to us, full of surprises and forever changing how we see our solar system and our place in it. When we look at the story of space exploration, there are some moments and images that go beyond just science. They become part of who we are as people. These pictures don't just teach us, they make us stop and think about where we fit in the universe. One of the most powerful images is the pale blue dot, taken by Voyager 1 back in 1990. Carl Sagan, the famous astronomer, suggested taking this photo. It's not just a technical achievement, it's a reminder of what it means to be alive on Earth. Picture this. Voyager 1 had finished its main mission, flying past the outer planets. Then, as it kept moving farther from us than anything we've ever built, it turned around and looked back at Earth, our home. From about 3.7 billion miles away, a distance that's hard to even imagine, Voyager 1 pointed its camera at Earth. The space between the spacecraft and our planet is almost beyond belief. The photo it took shows Earth as a tiny dot floating in a sunbeam. It might look small and unimportant, but it means a lot. That little dot is our whole world. Every mountain, every ocean, every living thing. That pale blue dot is everything we know. It's where all of our history has happened and where all our future will be. It's the sum of all human experience, floating in the huge universe. This image reminds us how small we are in the universe, but also how connected we are to each other. It's humbling, but it also shows that everyone on Earth shares this one home. On that tiny dot, every story has happened. Stories of love, loss, success, and struggle. Every happy moment and every sad one, every act of kindness and every argument, all took place here. Every person who has ever lived, every civilization that has come and gone, every laugh and every tear, they're all part of that single pixel, floating in space. The pale blue dot shows us how precious our planet is. It's the only home we have, and it's up to us to take care of it for the future. When we see Earth from this perspective, it's clear. We're all in this together. The sun is at the center of our solar system. It's a giant ball of hot, glowing gas, and its energy is what makes life possible here on Earth. Everything in our solar system, from the planets to the smallest dust, is shaped by the sun's power. The sun is always sending out a stream of tiny charged particles called the solar wind. This wind blows out in every direction, carrying the sun's energy far past the planets. The solar wind acts like an invisible shield, creating a bubble around our solar system. This bubble helps protect us from some of the dangerous radiation that fills the galaxy. Over time, the solar wind has carved out a huge bubble in space called the heliosphere. This is the area where the sun's influence is strongest, even far from the sun itself. Outside the heliosphere is the interstellar medium. This is the space between the stars, filled with thin clouds of gas, dust, and cosmic rays. It stretches for incredible distances. The very edge of the sun's bubble is called the heliopause. Here, the solar wind slows down and mixes with the material from the rest of the galaxy. In 2012, after more than 30 years of traveling through space, facing the dangers and cold beyond the planets, Voyager 1 did something amazing. It crossed the heliopause. It left the sun's protective bubble and entered a new part of space we had never explored before. By doing this, Voyager 1 became the first human-made object to enter interstellar space. It went farther than any spacecraft before it. This moment was a big step for us. It opened the door to exploring the huge, mysterious spaces between the stars. Now Voyager 1 is in a place between the stars. It's almost completely empty, and the closest star is many light years away. Just think about it. The space between stars is so huge that even light takes years to cross it. Out here, the only thing around is a faint background of cosmic radiation, signals that have been traveling across the galaxy for millions of years. This is where Voyager 1 is now, a place full of mystery, where the rules we know from our solar system start to change. It's a place with endless possibilities. Every bit of data Voyager sends could help us learn more about how the universe began and what might happen to it. Sending a spacecraft this far shows what humans can do when we're curious and determined to learn more. Voyager 1 carries our hopes and dreams. It's a quiet messenger, moving through the vastness of space. Out there, in the emptiness between the stars, Voyager 1 keeps going, moving deeper into the unknown. Even now, it still sends back weak signals, tiny bits of information from far away, helping us learn about places we can't visit ourselves. These signals are like clues, helping us piece together the story of the universe. Voyager's journey could last for thousands of years, drifting farther and farther from Earth, its story living on. Even after we're gone, Voyager 1 will still be out there, a silent witness to our time, carrying our message into the endless night, always moving forward into the unknown. As Voyager 1 moved farther away from our solar system, it started to hear something strange, a quiet, steady hum coming from deep space itself. This hum is actually a low-frequency radio signal coming from the plasma, or charged gas, that fills the space between stars. Scientists have been fascinated by it ever since they first noticed it, because it gives us a new way to study what's happening out there in our galaxy. People sometimes call it the cosmic hum. Even though space seems empty, this gentle background noise reminds us that there's always something going on, a constant flow of energy and information. You can picture these plasma waves like ripples moving through the fabric of space, carrying energy and messages across huge distances. They help us see the hidden patterns and movements in the universe. These waves also show us how complicated and sometimes wild the space between stars can be. It's not just empty, it's full of activity and beauty, even if we can't see it with our eyes. Scientists are still trying to figure out exactly where the cosmic hum comes from, but it probably has to do with how charged particles in the plasma bump into each other and move around. It's like a quiet dance that creates this mysterious sound. You can think of it as a soft echo from all sorts of cosmic events. Distant stars, exploding supernovas, each one adding its own note to this background music of the universe. Even after all these years, Voyager 1 is still out there, listening to this cosmic hum with its old but reliable instruments. The data it sends back helps us learn more about what's really happening in interstellar space. Voyager's journey is proof of how powerful curiosity and exploration can be. By reaching into the unknown, we keep discovering new things about our universe and ourselves. As our Voyager probes journey through the vastness of interstellar space, they are uncovering the detailed structure of our cosmic neighborhood, filled with stars, planets, and other cosmic wonders. We've learned that our solar system isn't just floating alone in space. It's part of a bigger, interconnected cosmic web. It's situated within an area astronomers call the local bubble, a fascinating and complex structure. Picture a bubble about 1,000 light-years wide, a cavity created in the interstellar medium by the powerful winds of stars that died long ago, shaping the space around us. It's a region of thin gas, much less dense than the space around it, creating a unique environment for our solar system. This bubble, our cosmic home, wasn't always so empty. It has a dynamic history shaped by powerful cosmic events. Millions of years ago, a series of supernova explosions, the violent deaths of massive stars, sent shockwaves through the interstellar medium, carving out this vast cavity, leaving behind a region of space that is both mysterious and revealing. These stellar explosions, once fiery cataclysms, transformed the interstellar landscape, leaving behind a region of hot, diffuse plasma, a testament to the powerful forces at play in our galaxy, less dense than the surrounding interstellar medium, creating a unique environment for exploration. And it's through this bubble, shaped by ancient cosmic events, that our Voyager probes are currently traveling, uncovering new secrets. Their instruments, still diligently collecting data, are providing us with invaluable insights into the nature of this bubble and the forces that shaped it, helping us piece together the history of our cosmic neighborhood. Each bit of information beamed back brings us closer to understanding our place in the grand tapestry of the cosmos and the intricate dance of celestial bodies that make up our universe. The Voyager mission continues to be a beacon of human curiosity and ingenuity, pushing the boundaries of our knowledge and expanding our horizons. The Voyager probes are more than just advanced scientific tools flying through space. They are silent messengers, carrying the hopes, dreams, and curiosity of all humanity. Like messages in a bottle set adrift in a vast ocean, these spacecraft travel through the unknown, carrying a special cargo meant for anyone who might find them someday. Each Voyager has a golden record attached, a carefully made time capsule designed to keep a snapshot of life on Earth at the time of their launch. These records are not meant for us or any immediate audience. Instead, they are a message to the unknown, a cosmic calling card for any extraterrestrial intelligence that might find these spacecraft as they travel between the stars. On each record are detailed diagrams showing step-by-step instructions on how to play the sounds and images stored inside, so even beings very different from us might understand its contents. There are greetings in 55 languages, spoken by people from all over our planet, showing the amazing diversity of life and culture on Earth. We've included images of our planet, its beautiful landscapes, its many creatures, and the faces of its people, offering a glimpse into the world we call home. And perhaps most touchingly, we've added music, a universal language that goes beyond words and speaks directly to the soul, sharing emotions and ideas that connect us all. From the timeless melodies of Bach, echoing through centuries of human history, to the lively rhythms of Chuck Berry, capturing the energy of modern times, the Golden Record carries a symphony of human experience, a rich mix of sound and culture for the cosmos to hear. It's a testament to our creativity, our ingenuity, and our enduring hope. A message that even in the vastness of the universe, we reach out, longing to connect and to share the story of who we are. For over 40 years now, the Voyager probes have been traveling farther than anything humans have ever built. They're out there, quietly moving through space, acting as our messengers to the universe. These spacecraft have gone beyond the planets in our solar system, showing us things we never thought we'd see and helping us learn more about the universe. But even for these amazing explorers, time keeps moving. The Voyagers are still going, getting farther from Earth than anything else we've ever made. Their power comes from plutonium, which slowly runs out as it decays. Every year, there's a little less energy to keep their instruments working. Scientists think that by around 2025, the last of the Voyager instruments will have to be turned off. One by one, the tools on board will stop working. They won't be able to collect or send back any more data from the edge of interstellar space. Eventually, the Voyagers won't be able to send signals back to Earth at all. Our connection to them will end. But even when we can't hear from them anymore, their journey keeps going. The Voyagers will drift on, deeper into space, untouched and alone. At that point, the Voyagers become silent ambassadors. Each one carries a golden record, a kind of time capsule with music, greetings, and sounds from Earth. These records will travel with the spacecraft for billions of years, long after Earth has changed in ways we can't imagine. The Voyagers will become like ancient artifacts, silent witnesses to the time when humans first reached out to the stars. They show just how much we want to learn and explore, and how curious we are about the universe and our place in it. Even when we can't hear from them, the Voyager's story will last. It's a reminder of what people can do when we work together and dream big. The Voyagers will keep inspiring new generations to look up, to wonder, and to dream about what's out there in space. Space is full of mysteries we haven't solved yet, and the Voyagers remind us that exploring never really ends. Their journey shows what humans can do with creativity, hard work, and a desire to know more. The Voyager's story reminds us that our urge to explore is as big as the universe itself. No matter how quiet their journey gets, our curiosity will always push us to reach for the stars. Even in the super clean, controlled environment of a lab, where everything is sanitized and spotless, mistakes can still happen. Human creativity is amazing, but perfection is always just out of reach. Out there, billions of miles from Earth, hit by cosmic rays and barely touched by sunlight, the Voyager probes show our drive to explore and the skill of the engineers who built them. These spacecraft aren't just machines, they're symbols of our quest to go beyond what we know. Think about it. These probes, launched in the 1970s, are still working. Decades have gone by, technology has advanced, but the Voyagers keep sending data from the far edges of our solar system and beyond. They're like time capsules of technology, still working thanks to the incredible engineering of the Cold War era. Every part was designed with such care and foresight that it still impresses engineers today. But space is tough. The environment out there is harsh, and survival is never guaranteed. It's not just the huge distances and freezing cold that threaten these spacecraft. There are countless dangers lurking in the darkness. Spacecraft, even ones as well built as the Voyagers, face constant radiation, impacts from micrometeoroids, and the slow wear and tear of time. Every day, they endure conditions that would destroy most machines in moments. And yet, they keep going. Against all odds, these tiny ambassadors of Earth continue their journey, defying expectations year after year. Voyager 1, in its old age, has shown us that even in deep space, machines can surprise us, almost like they have a personality. It's as if the probe itself refuses to give up. A few years back, Voyager 1 started sending back data that puzzled even the most experienced engineers. The signals were strange, the information confusing, the telemetry was garbled, nonsensical. It was as if the spacecraft was speaking in riddles, its once clear voice now lost in static. Was this the end for the little spacecraft that could? Had it finally reached the limits of its endurance? Had it finally succumbed to the harsh environment of interstellar space? The team at NASA faced a huge challenge, one that seemed almost impossible. Well, this is where the story gets really interesting. Instead of giving up, the engineers rolled up their sleeves and got to work, determined to find a solution. See, the engineers at NASA, these are some clever folks. They thrive on challenges, and this was one of the greatest they had ever faced. They suspected that the problem was with the spacecraft's memory, maybe damaged by a cosmic ray strike. Cosmic rays are high-energy particles that can mess up electronics, especially after decades in deep space. Now imagine trying to diagnose and fix a computer problem from billions of miles away, with a signal lag of, well, days. Every command sent takes hours to arrive, and every response takes just as long to return. It sounds impossible, but that's exactly what the NASA team did. They refused to let distance or time stand in their way. They dug through old software manuals, ran simulations, and finally, after months of hard work, they found a solution. It took patience, creativity, and a deep understanding of both old and new technology. And against all odds, it worked. The team's perseverance paid off, and the spacecraft responded, its systems coming back to life. Voyager 1, our brave explorer, was back online, ready to continue its journey into the cosmic unknown. The mission was saved, and the probe continued to send back valuable data from the edge of interstellar space. It's a powerful reminder that even with advanced technology, sometimes a little creativity and a lot of perseverance are all you need to overcome even the toughest challenges. The story of Voyager's resilience is, in many ways, the story of humanity itself, undaunted, resourceful, and always reaching for the stars. You know, we used to think space was just a big, empty nothing. But it turns out, space is actually full of invisible stuff. Energy, particles, and all kinds of things we can't see with our eyes. It's like a giant hidden web that stretches way beyond what we can imagine. Space is buzzing with energy and tiny particles, moving around and creating waves. It's almost like the universe is playing its own quiet music, with all these forces and events working together to shape everything out there. Just like we tune radios to catch signals from far away, Voyager has given us a new way to listen to space. As it travels beyond the edge of our solar system, its instruments pick up the faintest signals, letting us hear things we never could before. One of the coolest things Voyager found is a quiet, steady hum out there. This signal is really faint, almost lost in the background, but it hints that there's a lot going on beyond our solar system. This isn't the sound of stars blowing up or black holes smashing together. It's not loud or dramatic. Instead, it's something much softer and always there. What Voyager is hearing is the sound of interstellar plasma. That's the thin gas and charged particles floating between the stars, and it's always moving with energy. These plasma waves are like the gentle background noise of the universe, showing us that even the emptiest places are full of activity. The hum is really low, way too low for us to hear, but Voyager's sensitive instruments can pick it up. Thanks to these detectors, we've discovered a hidden part of space we never knew existed. Picture a huge ocean, but instead of water, it's filled with tiny charged particles, electrons and protons, always moving and interacting. We can't see this ocean, but it shapes the space between the stars and carries energy and information across huge distances. This is what scientists call the interstellar medium. The hum Voyager hears is the sound of this medium always moving, a kind of heartbeat in the emptiest parts of space. It's a living environment, full of tiny interactions and mysteries we're just starting to understand. Discoveries like this have made us rethink what we know about space. Voyager keeps showing us that space is more complicated and interesting than we ever thought. Interstellar space isn't just empty and quiet, it's always changing, with its own wonders and mysteries. The universe is full of movement, energy, and the constant dance of particles and waves. As Voyager keeps moving farther into space, who knows what else it might find? Every mile it travels helps us learn more about the universe, reminding us that even in the quietest parts of space, there are stories to discover and mysteries waiting for us. For a long time, people looked up at the night sky and thought the space between the stars was just empty, nothing but a huge, silent void stretching out forever. But just like we've found life in the most extreme places on Earth, like deep ocean vents or dry deserts, we're learning that space between the stars isn't empty at all. Instead, it's filled with a thin mix of particles, dust, and magnetic fields. Scientists call this the interstellar medium. It's a strange and active place that stretches between the stars. You might imagine it's like a thick fog or a cloud you could see or touch, but the interstellar medium is much more delicate, almost like a ghost, barely there at all. Imagine taking a single grain of sand and spreading it out over the whole Earth. That's how thin this stuff is. You could travel for years and not bump into a single atom. That's the kind of low density we're talking about. It's hard to picture, but this thin material is everywhere between the stars. Even though it's so spread out, this material is super important. It helps shape galaxies and affects how they change over billions of years. It's also where stars are born. Gravity pulls together gas and dust from the interstellar medium, and when there's enough, a new star lights up. The interstellar medium is the raw material for stars, planets, and even life. It's like a giant supply of building blocks for the universe. It's also the place where the energy and heavy elements from exploding stars, supernova, get spread out, making new stars and planets richer in elements. Before Voyager, we mostly guessed what the interstellar medium was like. We used models, indirect measurements, and observations from far away, always looking through the filter of our own solar system. But Voyager changed that. It was the first spacecraft to actually go out there and measure this strange environment directly. And what Voyager found surprised us. It made us rethink a lot of what we thought we knew about interstellar space. For example, the plasma out there is actually cooler and denser than we expected. The environment is more complicated and active than our old models showed. And the magnetic field in interstellar space? That was a surprise too. Voyager showed us that the magnetic field out there is much stronger than scientists thought. This changes how we think about the galaxy, how cosmic rays move, and how the interstellar medium is shaped. These discoveries are helping us understand how galaxies grow and change, how stars are born and die, and how the ingredients for life spread across the universe. Voyager's trip through interstellar space is a bit like a ship sailing across an unknown ocean, finding new currents and mapping new places as it goes. Every day, Voyager uncovers new details, new mysteries, and new knowledge about this vast space. Every bit of data it sends back, every signal, helps us build a clearer, richer picture of where we are in the Milky Way. It reminds us that, even in the huge emptiness of space, everything is connected by a web of particles, energy, and the ongoing story of the universe. Picture this. There's a huge sphere way out beyond Pluto, so far away that Pluto itself looks tiny in comparison. This is what scientists call the Oort cloud. It's a region we think is filled with icy leftovers from when our solar system first formed, billions of years ago. These icy objects come in all sizes. Some are smaller than mountains, while others are even bigger than planets. They drift out there, barely held by the sun's gravity. The Oort cloud might stretch almost a light year from the sun, wrapping our solar system in a distant, icy shell. Every so often, something like a passing star or the pull of our galaxy can disturb one of these icy bodies. When that happens, it can send the object speeding toward the inner solar system, where we see it as a long-period comet. These comets, with their bright glowing tails, are some of the most amazing sights we can see in the night sky. The Oort cloud is like a cosmic graveyard, holding on to the building blocks that helped create our solar system. It's proof of how wild and active things were when the solar system was young. planets moving around and icy debris getting flung far away by gravity. The Oort cloud is like a frozen time capsule, holding secrets about how everything here began. We haven't actually seen an object in the Oort cloud up close yet, but there's a lot of evidence that it's real. The comets we see, with their glowing tails, give us hints that there's a huge collection of icy bodies way out there, just waiting to be discovered. The Oort cloud is still one of the biggest mysteries in our solar system, a distant halo that could help us understand where we came from. Maybe someday, with better technology, we'll send a probe out there to explore and learn more about these icy wanderers. For now, we can only watch the comets that visit us. Each one is like a messenger from the far edge of our solar system, reminding us of the vast and mysterious Oort cloud that's still out of our reach. The sun is basically a giant ball of burning gas, powered by nuclear fusion, and it's been shining for more than 4.5 billion years. All the time, it sends out a steady flow of charged particles called the solar wind. These particles shoot out in every direction, moving incredibly fast. The solar wind is made of tiny pieces called electrons and protons. They travel through space, shaping the environment around our solar system. As this wind moves outward, it creates a huge bubble around our solar system. Scientists call this bubble the heliosphere. The heliosphere acts like a shield, protecting us from the thin mix of gas, dust, and cosmic rays that fill the space between stars. The very edge of this bubble, where the solar wind's push is balanced by the pressure from space outside, is called the heliopause. The heliopause is the outer limit of the sun's influence. It's the last border of our solar system. Beyond this invisible line, we leave our familiar solar system and enter the huge, mysterious space between the stars, a place we still know very little about. The Voyager spacecraft are the first human-made objects to cross this boundary. They've sent back important data that's changed how we understand this far-off region at the edge of our solar system. Thanks to Voyager, we now know the heliopause isn't a smooth, simple surface. Instead, it's a rough, ever-changing area, always shifting as the solar wind and the material from outside space push and pull on each other. This region is shaped by the way magnetic fields, plasma, and energetic particles interact, making it a lively border between our solar system and the rest of the galaxy. Crossing the heliopause is a huge step in space exploration. It's kind of like leaving Earth's atmosphere for the first time, but on a much bigger cosmic scale. This moment marks the start of a new chapter for humanity, as our spacecraft travel into places we've never been before, beyond the sun's reach. Now, we're on a journey far beyond our solar system, into the wide, mysterious galaxy, a journey that's just beginning, with so much more to discover out there. When Voyager 1 set out into the unknown, leaving our solar system behind and heading into interstellar space, its twin, Voyager 2, was on a different but equally amazing journey. Voyager 2 took a path that let us discover some of the most surprising things about the planets in our neighborhood. In 1986, after almost 10 years traveling through the cold, empty parts of space, Voyager 2 became the first, and still the only spacecraft, to visit Uranus. Uranus had always been a bit of a mystery, with its pale blue-green color and an atmosphere that's different from any other planet in our solar system. Out there, about 1.8 billion miles from the sun, sunlight is just a faint, cold glow. Voyager 2 showed us that Uranus is really unusual. It's tilted almost completely on its side. Its axis is tilted by nearly 90 degrees, which makes it stand out from all the other planets we know. Just imagine living on a planet where for decades, the sun barely rises above the horizon. The shadows are long and strange, stretching across the icy ground. The seasons on Uranus last for years, with long periods of light and darkness that are nothing like what we have on Earth. Scientists think this strange tilt happened because Uranus was hit by a huge object, maybe another planet, a long time ago. That collision changed Uranus forever. Voyager 2 also found out that Uranus, like Neptune, is part of a group called the ice giants. Ice giants are different from the gas giants like Jupiter and Saturn. They're made mostly of heavier elements like water, ammonia, and methane, not just hydrogen and helium. That's what gives them their unique colors and thick, layered atmospheres. Their cold atmospheres are full of storms and clouds, hiding deep layers that we're only starting to understand. Studying these ice giants helps us learn about how planets form and change, not just in our solar system, but maybe in other star systems too. Voyager 2's visit to Uranus gave us new ideas about how planets grow, evolve, and interact with their surroundings. It showed us just how many different kinds of worlds exist in our solar system, from gas giants to rocky planets, and now the mysterious ice giants. Voyager 2 proved that space is full of surprises, and every discovery leads to even more questions and mysteries to explore. As we look ahead to a new age of space exploration, it's amazing to think about how far we've come and how much more there is to discover. The Voyager probes remind us just how curious and brave humans can be, always reaching out to learn more about the universe. These spacecraft were launched back in the 1970s, at a time when people were full of questions and ready to push the limits of technology. Even now, Voyager keeps sending us tiny signals from deep space, carrying the hopes and dreams of everyone who's ever looked up at the stars. These signals show what people can do when we work together. Scientists, engineers, and dreamers from all over the world. But Voyager's mission isn't just about science. It's also about meaning. About reaching out, making a connection, and leaving something behind in the universe. Each Voyager carries a message of hope, curiosity, and the spirit of exploration that brings people together, no matter where they're from. The golden record on board was made to show the diversity and unity of life on Earth. It has greetings in 55 languages, spoken by people from all over the world, reaching out across space. There's music too, songs and sounds from many cultures, sharing the feelings and creativity of humanity. And there are pictures, scenes of nature, people, and life on Earth, giving anyone who finds it a glimpse of who we are. It's like a message in a bottle, floating through the huge dark ocean of space, hoping to be found. Voyager keeps drifting, carrying our story, waiting for the chance that someone or something might discover it one day. The odds of another civilization finding Voyager are incredibly small, almost impossible to imagine. But just knowing it's out there makes us wonder and dream about making contact with life beyond Earth. It sparks our curiosity about our place in the universe and makes us want to understand more about where we fit in. Voyager shows the best of what people can do, our creativity, our curiosity, and our drive to explore, even when it's hard. These spacecraft are the result of years of hard work, new ideas, and a passion for learning that defines us as humans. Voyager is a link to our past and a sign of hope for our future, carrying Earth's story far beyond our solar system. It stands for our ongoing search to solve the mysteries of the universe and to answer questions we haven't even thought of yet. Voyager's journey is almost over, as its power fades and its signals get weaker, but its story will keep inspiring new generations to reach further and dream bigger. Voyager's legacy reminds us that our ability to discover is as endless as the universe, and our journey is just beginning. For over 40 years now, Voyager 1 and Voyager 2 have been traveling farther than anything humans have ever built. Along the way, they've changed how we see our solar system, and even how we think about our place in the universe. These two spacecraft have shown us what's out there beyond the edge of our solar system. They've gone past the sun's protective bubble and into interstellar space, where things get really interesting and mysterious. Their journey reminds us just how huge and full of surprises the universe is. There are so many stars, galaxies, and possibilities out there, way more than we can see from Earth. The Voyager story is really a story about us, about human curiosity and our drive to explore. It shows what we can do when we work together and push past what we thought was possible. If you enjoyed this journey as much as we did, please hit the like button and let us know you're interested in more space adventures. We'd love to hear what you think. Share your questions or ideas in the comments. Your curiosity helps keep us going. And don't forget to subscribe if you want to join us for more deep dives into space. That way, you won't miss any new discoveries. By subscribing, you're joining a worldwide group of people who love space and science, people who are just as curious as you are about what's out there. Thanks for watching and for being part of this adventure. Next time you look up at the night sky, remember, our search for knowledge never stops, and there's always more to discover. Until next time, stay curious, keep asking questions, and most importantly, keep looking up.